Hi, boys and girls. This is Mrs. Schonklipper. I'd like you to take out your books and open up to page 425. That's 425. We are doing lesson 21, session 1, and we're going to just explore the idea of multiplication is a form of scaling a number, and we will talk about what that is. But pretty much in this lesson, these are the things we're going to think about. What happens when you multiply a fraction times something? What happens to that something? We're going to think about what happens when you multiply a whole number or a mixed number or an improper fraction by something. What happens to that something? And finally, what happens when you multiply 1 by something? Okay, and what you should have answered when I asked you those things is you should have been thinking about what happens to the something. Does it get bigger? Does it get smaller? Does it stay the same? So that's what we're going to be taking a look at in lesson 21. So let's start. So this says multiplication as scaling, and then first it starts off by saying, what does scaling even mean? So we're going to model it, and let's complete the problems below. Number 1, changing the size or the quantity by multiplication is called scaling. So we're changing the size of something by multiplying. Stretching and shrinking are two different ways to scale a quantity. In other words, stretching something or shrinking something are two ways to change a number. That makes it sound confusing. Let me just show you. This bar has a length of 6 units. 1, 2, 3, 4, 5, 6. Use the bars at the bottom of the page to complete parts A and B. Now it says, circle the bar, so it's either going to be this one or this one. Circle the bar that shows the length of 6 units being doubled. So do you know what doubled is? Do you play baseball? Do you know what a double is? When someone gets to the second base, or if you have to double a recipe, what's happening when you double? You multiply it by 2. So you need to circle the bar that shows the length of 6 being doubled, or in other words, stretched out. So which one of these should you circle? You should circle this one here. So go ahead and do that. So it told us to circle the bar. Check, we're done. Then it says to underline the bar that shows the length of 6 units being halved. What happens if I don't want a whole piece of pizza? I just want a half a piece. Maybe I'm starting to get full and I don't think I can eat that whole last piece, so I just want half a piece. What does it mean to half something? Does it mean to split it in 2? To cut it in half? To find half of it? Does it also mean to shrink it? So underline the bar that shows 6 being halved or shrunk. So I knew this one was doubled. I could see that it was doubled, and I'll prove it with numbers. What would double 6 be? 12. And what would it be to half 6? 3. So then it said underline the bar that shows the length of 6 being halved or shrunk. So underline that and done. Now we have to write a multiplication equation for each bar. We can do that. Circle the factor that describes how the length has been stretched or shrunk. Okay, so we have to first write a multiplication equation. So they said multiplication equation. Equation has an equal sign. Multiplication equation. So what's happening here? I have doubled 6. So 2 times 6, and that gives us 12. And then over here, what did I do? I halved it. So I did half of 6 equals 3. So there's my equations. Write a multiplication, equation. Now circle the factor that describes how 6 has been, in other words, changed. So which factor shows that 6 has changed? This factor right here. Remember, it's factor times factor equals product. And this factor right here shows how that has been changed. So all we're saying is we can take numbers, we can use multiplication, and we can either make them bigger or smaller. That's really all that this is showing. Okay, page 426. Use the table to make generalizations about scaling the whole number 6 through multiplication by various factors. So we're going to use the table. We're going to make generalizations, like we're going to make like a rule about scaling the whole number. So that's changing. So we're going to change the whole number 6. Here's 6. We're going to change the whole number 6 through multiplication. We're going to change it by multiplying by various factors. So here's a whole bunch of different factors. Here is 6, and here is the answer. Okay. So like if you do, let's just do, well, yeah, we'll start here. What's 1/10 of 6? 6/10. What's 1/3 of 6? 2. What's a half of 6? We did that. 3. What's 1 times 6? 6. What if we write 1 this way? 4/4. Isn't that 1? Isn't that a form of 1? Isn't that a number 1 in disguise? So what's 1 times 6? 6. This, doesn't it say 1.5? What's 1.5 groups of 6? So what this means is not only do you have one group of 6, but you also have an extra half of 6. 9. Ooh, 2.5 groups of 6. So that's one group of 6, two groups of 6, and plus another half a group of 6. That's a lot more than 6. And then finally over here it says 3 groups of 6. Remember when we have whole numbers, or we have mixed numbers, or we have improper fractions, we can say groups of. Do you remember that? Groups of. And when we have fractions over here, remember we can say part of. Of means multiply. And then the fractions mean part. And then the whole numbers, the mixed numbers, the improper fractions, those are all bigger than 1, so we can say groups. All right, now we can answer these questions. A, underline the products less than 6. Here's the product. This is less than 6. This is less than 6. This is less than 6. Done. What do the factors for these products have in common? So what do all of these things have in common? Do you know? They are less than 1. I guess I should use a complete sentence. They are less than 1. B, circle the products greater than 6. This is greater than 6. This is greater than 6. And this is greater than 6. What do the factors for these products have in common? They are, what do you notice? Greater than 1. Put a box around the products that are equal to 6. Boom, boom. What do the factors for these products have in common? They are, do you know what I'm going to say? Equal to 1. Describe the products you get if you multiply 8 by factors less than 1. Let's stop there. If you multiply 8 by factors less than 1, I haven't done any writing. All I did was steal. It says describe the products you get if you multiply 8 by factors less than 1. So I just stole this. If you multiply 8 by factors less than 1, comma, I'm still stealing words, the product will be, okay, so what happens when you multiply by factors less than 1, factors less than 1, the product will be less than what you're using. So if you multiply 8 by factors less than 1, the products will be less than 1. They use the number 1, so I can use it too. So in other words, if you multiply 8 by something less than 1, if you say a half of 8, what is a half of 8? 4. So you're multiplying 8 by a factor less than 1. Your answer is going to be, not less than 1. Less than 8. Sorry about that. Teachers goof up too sometimes. Good thing I really thought about it. So if you multiply 8 by factors less than 1, the products will be less than the 8. Whew. Describe the products you'll get if you multiply 8 by factors greater than 1. All right, I'm going to steal this same sentence. If you multiply 8 by factors greater than 1, comma, the products will be, so now if we use something greater than 1, so if we do like 3 groups of 8, the products will be greater than 8. Make sense? If this is less than 1, this ends up being smaller than that. So this little guy turns the 8 littler. This 3, this big guy, turns the 8 bigger. And this is something you probably realized as we were doing fractions. Because remember when we started, you guys are like, wait, when you multiply, you're supposed to get a really big answer. Well, when you were little, you got a really big answer. But now that we're working with fractions, sometimes when you have this fraction, it makes that smaller. Okay, so a fraction makes this smaller. A mixed number, a whole number, an improper fraction makes this number bigger. And then a 1, what does it do to the number? It keeps it the same. All right, next page, 427. And I'm going to let you copy this down. It talks about scaling. Scaling can mean to stretch a number to make it bigger, can be to shrink a number, make it smaller. Scaling means to resize by multiplying. Different ways you can resize or different examples of scaling. You can multiply by 1. It does not scale the number. It actually keeps it the same. You can multiply by 2 and that doubles the size of a number. Or you can multiply by a half and it makes half the size. So pause here and copy that down. Next up is number 2. I want you to try this one by yourself. It says complete the sentences to describe 2 kinds of scaling. So this is the shrinking and this is the stretching. When I multiply the whole number 6 by a fraction less than 1, so a fraction less than 1, that's something small, the product will be, and you have to compare it to the 6. What's it going to do to the 6? So you'd have to put a word here like greater than or less than 6. For this one, when I multiply the whole number 6 by a fraction greater than 1, so that's something big, the product will be, and then you have to compare it to the 6. Is it going to be greater than or less than the 6? So go ahead and pause the video and do that now. Okay, did you figure it out? If you have something small, a fraction less than 1, and you're multiplying it by 6, it's going to shrink the 6. So your product or your answer will be less than 6. And if you multiply it by something bigger than 1, the product or the answer will be greater than 6. Okay? Almost done. We've got one more page. Page 428. This bar has a length of 8 units. This bar shows the length of 8 units scaled. Use words to describe how the length of 8 units is scaled. Can you see it? So how is that scaled? I'm going to steal these words. The length of 8 units is, I'm going to make sure that's a capital. I meant it to be, but it was kind of messy. The length of 8 units is doubled. And that's the word that means multiply by 2. If you want to add another sentence, it has been stretched. And that's one of the scaling words. So it has been stretched to twice the length of the original bar. Okay, so twice, doubled, times 2, it all means the same thing. Write a multiplication equation to show how the length is scaled. This is my favorite part. Multiplication says equation to show how the length is scaled. So you can either start with like what's happening, like you can say what's happening to the 8 and put it that way, or you could even start with the 8, say because I started with 8 and then what's happening to it, it's being multiplied by 2 to get the 16. Either way is fine. Okay, number 4. I have a feeling it's going to be this same thing, but maybe the other way around. Number 4. This bar shows a length of 8 units scaled in a different way. It's not too hard to see what's happening here. Use words to describe how the length of 8 units is scaled. I'm going to copy the same setup. The length of 8 units is, and then what's the word? Halved. Now, here's a little English lesson. Half is this, but when you're saying it's halved, the F, you know how when you make this plural, the F turns into a V? So same thing here. Halved. The length of 8 units is halved. It has been, what's the word? Not stretched, shrunk. You know, when you put something in the dryer that's not supposed to go in the dryer and it shrinks, it's been shrunk. Or do you remember that movie? Well, you wouldn't remember, you guys weren't alive, but there was a movie called Honey, I Shrunk the Kids. It was kind of like a famous, iconic 80s movie. It has been shrunk to be, instead of twice the length, half the length. You copying this down? Of the original bar. If I'm writing it, you're writing it. You're joining in the torture with me. Write a multiplication equation to show how the length has been scaled. I love this. Multiplication equation to show how the length is scaled. So again, you can start with what's happening to the 8, or you can say I started with 8 and it's been halved to be 4. Does this look okay to you? There's nothing wrong with it. You're taking 8 and you're doing just half of it. This might feel a little bit better to you by writing half of 8. Either way is fine. Remember that commutative property, you can flip-flop. All right, everybody. Excellent job. Check Google Classroom, and it will tell you what to do next. It will probably say some MyPath, but I might have you watch a video or something. So just check Google Classroom and it will tell you what to do next. All right, thanks everybody. Good work.